Okay, today we are working with equations. And in your words worth knowing, you should have put in the definition of an equation as an algebraic expression. It's a mathematical statement that contains algebraic expressions with an equal sign. And we can find those unknown variables in our algebraic expressions, in our equations, given a set of numbers for possible replacements. In our example here, we are given two replacement sets, A and B, and we are given four equations. We're going to try to find the solutions for these equations, meaning we are going to try to find values of our unknown variables that satisfy this equation. So in order to do that, I set up a table for all four of these, for 1 through 4. And I put my replacement set over in this first-hand column. Now my first two equations are referring to replacement sets A for 1 and 2, and for 3 and 4 I'll be using replacement set B. So I put 4, 5, 6, 7, 8. That's what I have to test. I have to use substitution now to plug in for my values. Using the order of operations, I have to take 5 times 4 minus 9. Or this is 20 minus 9, which is 11. In this column here, I put what's to the right of my equal sign, which is 26. And now I test this out to see if 4 is a solution to my equation. Does 11 equal 26? Well, no, it doesn't. So this is false. So 4 cannot be a solution to this equation. And I do the same thing for 5. 5 times 5 minus 9. So this is 25 minus 9, which is 16. It is also not equal to 26. So 5 is not a solution. Now I'm going to try 6 times 5 minus 9. This is 21. It's not equal to 26. So this one's false. Now I'm going to take 7 times 5 minus 9. This is 35 minus 9, which is 26. So I have 26 equal to 26. This is a true statement. So 7 is a solution. And now I'm going to try 8. 8 times 5 minus 9, or 40 minus 9, which is 31. It's not equal to 26, so this is false. So based on my solution set, my replacement set, my solution for this equation is just the number 7. 7 works here. I'm going to do the same thing over here for 4a minus 8. I'm going to plug in 4, 5, 6, 7, and 8. I'm going to take 4 times 4. I'm just substituting in. So 16 minus 8 is 8. So this is false. Now I have 4 times 5 minus 8. So 20 minus 8, which is 12. False. 12 is not equal to 16. 4 times 6 minus 8. So 24 minus 8 is 16. All right, I found one solution to my equation. 4 times 7 minus 8, 28 minus 8 is 20. So this is not a solution. 32 minus 8 is 24. It's not equal to 16. So up here, my only solution is the number 6. See how that works. All right, down here I'm going to use the replacement set B because the unknown variable in 3 and 4 is the letter B. So in these, let's see, I've got 9, 10, 11, 12, and 13. So now I'm going to take 4 times 9 minus 12. So 36 minus 12 is 24. And that's not equal to 28, so false. 4 times 10 minus 12 is 40 minus 12, and that is 28. So this is true. 4 times 11 minus 12 is 44 minus 12. (44 minus 12 is 32. So this is false. 4 times 12 minus 12, this will be 48 minus 12, which is 36. It's not equal to 28. This is false. And then I have 4 times 13 minus 12, which is 42 minus 12. Nope, 52 minus 12, which is 40. And it's not equal to 28. So you see how this works. See if you can fill in this side by yourself. So B is 9, 10, 11, 12, 13. The first one will be 36 divided by 9 minus 3. See if you can do that one. I would have 4 minus 3, which is 1. It is not equal to 0. And then this would be 36 divided by 10 minus 3, which would be 3.6 minus 3, which would be 0.6. False. 36 divided by 11 minus 3. Might need a calculator. Can you maybe find the pattern? Here we go. This one's 36 divided by 12 minus 3, so this is 3 minus 3, which is 0. I found my true statement. Another way to make a table of values, down below here, given an equation, I have a replacement set. I have two variables in my equation. I have y is equal to 3x plus 5. And I've been given a replacement set of -2, -1, 0, 1, 2. So to make a table of values, this replacement set is for the x values. I'm going to plug these in for x and then find out what my y value will be. So I plug in -2 for x. 3 times -2 is -6 plus 5 is -1. I do the same thing for -1. 3 times -1 is -3 plus 5, +2. When I plug in 0 for x, 3 times 0 is 0 plus 5 is 5. 3 times 1 is 3 plus 5 is 8. When I plug in 2 for x, I get 3 times 2 is 6, plus 5 is 11. So that's how you make a table of values given this replacement set. These are for the x values. You plug those in, you substitute, use the substitution property, you substitute for x to find out what your y is.